Hey everyone, and welcome. Today we're going to jump headfirst into the world of real-time operating systems, an RTOS. We're actually going to build our very first multitasking project, and trust me, it's way easier than it sounds.
Okay, so have you ever looked at your smartwatch and just wondered, how in the world is it doing so many things at once? I mean, it's tracking your heart rate, buzzing with notifications, updating the time, all at the same time? How does it not just, completely freak out?
Well, the answer, the magic ingredient, is a real-time operating system. And today we're going to get hands-on with one of the biggest names out there, FreeRTOS. Our playground for this is going to be the awesome and super affordable ESP32 microcontroller. So let's dive right in. All right, so here's the game plan. We'll kick things off with our project, talk about the specific flavor of FreeRTOS we're using, get our environment set up, code up a task, and then I'm going to leave you with a cool little challenge. So we're kicking things off with the classic hello world of the hardware world, blinking an LED. But hold on, we're not just making a light flash on and off. We're giving it a major upgrade. We're building a smarter Blinky, taking a basic one-track mind program and turning it into a real multitasking powerhouse. Okay, first things first, let's get a key concept out of the way. It's super important to know that not all FreeRTOS versions are created equal. And the one that comes with ESP32, yeah, it's a little bit special. Think of it like this. On one side, you've got vanilla FreeRTOS. This is the standard, off-the-shelf version you'd get straight from the source. But on the other side, you have what's bundled with the ESP32's official toolkit. Espressif, the folks who make the ESP32, took the vanilla version and added their own special sauce, tweaking it to work perfectly with the ESP32's dual-core brain. So you might be asking, why did they even need to change it? Great question. It all comes down to something called symmetric multiprocessing, or SMP. All that fancy term means is that the ESP32 has two identical processor cores that share the same pool of memory. The original FreeRTOS was really designed for a single core, so Espressif had to give it an upgrade to handle two. Now look, dealing with two cores at once adds a whole other layer of complexity, and we don't need that headache right now. To keep things simple and really focus on the core ideas of an RTOS, we're going to do something smart. We're going to pin our code to just one of those cores. Okay, enough talk. Time to get our tools ready. We're going to use the Arduino IDE, because honestly, it's just the easiest way to get up and running. And hey, if you've never set it up for the ESP32 before, no sweat. It'll take like a minute, tops. It's just 4 super quick steps. First, pop into the Arduino IDE preferences and paste in the Espressif URL for the board manager. Done? Cool. Now, go to Tools, Board, and open the Boards Manager. In there, just search for ESP32 and hit Install on the one from Espressif Systems. Last step, just pick your specific ESP32 board from the Tools menu, and bam, you're all set. All right, this right here is the absolute core of what we're doing today. If you've ever touched an Arduino, you know all about setup and loop. Well, today we're graduating. We're moving beyond that single, endless loop and embracing the fundamental building block of an RTOS. The task. And really, a task is just a fancy name for a function that runs on its own, managed by the operating system. And here is the single most important difference you need to understand. In a standard Arduino sketch, when you write delay function, your processor just stops. It literally sits there, twiddling its thumbs, doing nothing until the time is up. It's blocking. But with FreeRTOS, we use vTaskDelay function. This is a total game changer. It's non-blocking. It basically taps the scheduler on the shoulder and says, hey, I'm going to take a nap for a bit. Feel free to run some other code. That is the secret to multitasking. So how does the scheduler know when to check in on all these different tasks? Well, it listens for a heartbeat. This is the RTOS tick timer. It's a tiny, dedicated hardware timer that ticks at a super regular, constant interval. We're talking like every millisecond. And every single tick, the scheduler wakes up, looks around, and decides which task gets to run next. And this shows it perfectly. Tick, the scheduler runs. Tick, the scheduler runs again. It's this constant, predictable rhythm that gives the RTOS the power to juggle everything. It's what creates that magical illusion of multiple things happening all at once. So, what are the ingredients for a function to qualify as a task? It's a pretty specific recipe. First, it can't return any value. It's a void function. Second, it takes one special parameter, a void pointer, which is how we can pass in arguments. Third, and this is key, it must have an infinite loop inside because tasks are meant to run forever. And finally, somewhere in that loop, you have to call vTaskDelay to play nice and let other tasks have a turn.
Okay, get ready for a big mental shift here. This is important. We write this function, but we never ever call it ourselves. Instead, what we do in our setup code is we basically introduce our function to the scheduler. We tell the scheduler all about it, hand it over, and from that moment on, the RTOS is the boss. It's in total control.
And this is the magic function that does the introduction. X task create pin to core. It looks intimidating, but it's not. Let's just walk through it. PV task code is just the name of our function. PC name is a text name for debugging, super useful. US stock depth is how much memory we're setting aside for it. We'll use 1024 bytes. PV parameters is for passing arguments, but we're not, so it's null. UX priority is its importance level, 1 is fine for us. And X-Core ID, well, that's where we tell it to stick to core 1. Oh, and a quick side note on that stack size. On an ESP32, you literally can't go below 768 bytes, even for a task that does nothing. So our 1024 value, that gives us a nice, comfy safety margin for our little blinky task. Okay, here's a really cool insider secret for anyone coming from Arduino. You know your setup and loop? On the ESP32, those are already running as a FreeRTOS task under the hood. The whole system is already up and running before your code even starts. That means the second we call that xTaskCreate function, our new task just springs to life and starts running alongside everything else. Okay, we've waded through the theory, we got our tools set up, now it's time for the fun part, the payoff. It's your turn to really see this in action, and I've got a little challenge for you.
So when you upload and run this code, what you're going to see is
So when you upload and run this code, what you're going to see is So when you upload and run this code, what you're going to see is So when you upload and run this code, what you're going to see is So here's the challenge I have for you. Can you make a second task? Just copy and paste the first one, give it a new name, change the delay to something different, make it faster or slower, then just create it and set up just like you did the first one. What you'll get is two tasks fighting for control of the same LED, and it creates this really cool, almost chaotic, random-looking blink pattern. And that really brings us to the final, big idea here. While that LED is blinking, just remember, because of VTask delay, the processor is just sitting there, totally free for hundreds of milliseconds between each and every blink. For a microcontroller, that is an absolute eternity. So the question I want to leave you with is this. What else could you be doing in all that free time? Reading sensors, updating a display, checking for Wi-Fi signals? Once you start thinking in tasks, the possibilities, well, they're pretty much endless.